Okay, Daniel, can you hear me?
Yep, I can hear you.
Okay, so good day and welcome everyone to our very first Pi and AI session organized by Mozilla Campus Club of SESL in collaboration with the BCS student chapter of SESL. I'm Hasarindu Perera, club lead of the Mozilla Campus Club of SESL. Let me introduce our speaker today. I would like to welcome Mr. Daniel Morgan. He's a system engineer and a DevOps consultant, and he's also an AWS community builder and the community moderator of the AWS AI ML community. Welcome, Daniel, to the session.
Thank you for having me.
Before we begin, we have a short message from Dr. Andrew, founder of the Deep Learning AI. So let me share it with you.
Hello, deep learners. I'm Andrew Ng, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Perera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
Yep, and that's really important work. Well, it's nice chatting, and now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, Hotel.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project. Or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
Okay, so without taking so much time, we will start the session now. Daniel, mic is over to you.
Yep. Okay. So it's breaking into AI, right? So we want to learn AI. We want to get started in maybe a career, or maybe you're just interested in it as a hobby, right? I do it more as a hobby for myself because I do system engineering for NPR. So the agenda, right? I'm going to go over some fundamentals to make sure that we all have an understanding of what AI is and the different categories of AI. The different types of machine learning that there are, as well as reinforcement learning. Reinforcement learning is where I got my start. And then how to get started, different tools, different places to go to get education besides deeplearning.ai, right? So as mentioned, I'm a community leader in the AWS machine learning community. I work as a system engineer as NPR, so I don't use machine learning at my job. And I got started back in 2019. There was an AWS scholarship available for machine learning, and it involved using AWS Deep Racer. I got the scholarship. I went through the nano degree, and I've continued using it and continued participating in the Deep Racer League ever since then. So why did I get started with machine learning when I typically don't have the typical background? You know, when you guys are probably thinking machine learning, you're thinking like mathematicians, you're probably thinking computer programmers, you know, people with computer science degrees. First off, I'm undereducated compared to my peers. I have a 2-year degree, and that's about it. Everything I know about IT, everything I know about systems engineering, it's all been self-taught. So at the time, I had learned Python for a previous job. I wanted to keep the skill sharp. I wanted not to forget how to use Python. And, you know, I find doing personal projects, right? Not additive value. Yeah, they're good for short term for memory and that, but it's like how you know, ability to showcase your skills and stuff like that. And that's what kind of drew me to Deep Racer, right? It gives you a lot of community recognition along with peers. It helps you connect with different networks. And I've been invited out several times to different AWS summits to help them with Deep Racer. So there's benefits being in the ML space, and there's definitely benefits being part of the Deep Racer community. It helped me strengthen my math and analytic skills, for example, because I haven't used math since probably I did calculus back when I graduated high school in 2001, and then college was 2011, where I did business math, so some algebra. That was about it. So AI fundamentals. So what is AI? It's basically getting a computer to do a task that a human normally would do. When did it start? It started actually all the way back in 1956. Some cognitive scientists got together and they coined the concept at Dartmouth of what AI is, and it's now exploded into what it is today only because of the technology advancements that we've had within the last few decades. And so when you're thinking of AI, you know, you're probably thinking about, you know, Mid-Journey, Stable Diffusion, AlphaGo. Those are actually what we call narrow AI. They're designed to perform a specific task. General AI is being able to do almost any task that you give it to it. We are not there yet with AI. The idea would be that it would completely mimic human behavior. So for example, I said Midjourney. This is an example right here, this picture of artwork that I actually did with Stable Diffusion. I took their code base and then I actually put in video restoration techniques because a hurdle you always run into when trying to do AI is system resources. You've got memory limits you've got to think about, you've got drive capacity, you've got compute capacity you've got to think about, and these are going to always be the hardest hurdles to overcome. And for example, to generate a small image, and I think this was about 64 by 64 originally, to try to generate that like at even 1080p, I needed 32 gigabytes of video RAM. No card has that. 24 is the max. And without doing some extensive rewrite of their code base, which right now is beyond my ability because, hey, I've only been in space for 3 years and I'm still learning. It's you've got to think of outside the box of a way of trying to solve your solutions. So I actually used a video restoration technique to upscale this image to be able to hit 4K. And, you know, I have this quote here from Walt Disney because a lot of times, you know, we all start talking about things we want to do. And there's a time where you've got to stop thinking and talking about what you do and just do it. Because otherwise you'll never get anywhere, which is kind of where I started out right when I was younger. Because like I said, I didn't graduate college until 2011. So 11 years after I graduated high school, I didn't go and get a degree. So what is machine learning? It's basically the process of using a computer algorithm to capture behavioral patterns based on input data and output data. Under hood, it's mathematics. However, you don't need an extensive math background to even get started. So if you're sitting here thinking, how can I get started and I don't have a math background? Well, you don't need one. A lot of the tools out there were made by bigger, better minds than me, and I just leverage them because the extensive documentation that's available. So there's 3 types of machine learning. We have supervised, unsupervised, and reinforcement learning. Supervised learning is simply using a labeled data set to train a model. There's typically 2 types. There's classification and regression. Classification is really good for using to being able to categorize stuff, you know, like, hey, you know, identifying an object like, hey, this is a shirt and these are a pair of pants. Regression excels at seeing relationships between dependent and independent variables. So it's really helpful for predicting numeric values, like predicting the housing market. That would be a good place to use something like that. Unsupervised learning, you do not use labels at all. Instead, the data set is analyzed and it looks for hidden patterns within the data without the need of a human. There are 3 subcategories to supervise. There's clustering. It's grouping unlabeled data based on different or similar types of data. This could actually be useful in like identity fraud. There's association. It uses different roles to find a relationship between variables and data sets. This is, for example, frequently used in recommendation engines. So like, you know, you might see on Amazon, hey, this is frequently brought together, or even on Netflix that, hey, you watch this movie, you might like this movie. There's dimensionality reduction. This method is used to reduce the number of features in a data set when the data set's too large. Reducing the numbers to input to a manageable size while holding the integrity. It could, so this could be used to remove, this type of one could be used to remove noise from like a a visual data set. So like if you have a noise in a movie, it could be used to actually reduce that and make the clear. And finally, reinforcement learning. Reinforcement learning, like I said, is where I got my start in AI. And this is literally self-teach. The AI is self-teaching itself. You're using certain amount of constraints to provide the model, and then you're teaching it same way you're teaching a dog. So when you're trying to train a dog, you give it a reward. And so reinforcement learning reinforces that is the same type of behavior where you have actions, you have input parameters, and then you're rewarding based off of those parameters. So, like I said, I got started in AWS Deep Racer. This is where I got my journey into machine learning. So AWS Deep Racer, what it is, it's a 1/18th scale model AI that you can actually train up in the cloud first. It's literally an integrated learning system around a reinforcement learning. Amazon makes it easy by doing a lot of the heavy lifting for you. And the only thing you have to provide is ingenuity to create a reward function to reward based off of parameters that are provided. And then just let it train itself and analyze, because you always want to analyze what the model's doing, because you can really tell early on when training a model. If you're not analyzing it, you'd waste time, because you can tell early on whether the model's going somewhere or not based off the analytics. So more about how this all works for reinforcement learning. So you have an agent, and the agent in this case is the car. So this car, for example, is taking images of the track of what it's seeing, and then it's using the model to make a decision based off of what it's seeing to take an action. So in the case of when it's training, the agent takes an action and then sees where it's at in the environment, which is basically the state. And then it takes the state and checks it against the reward function. And then it uses this information to keep updating itself. You'll update the model with weights. And these weights end up being just probability, right? So it's like, hey, I've seen this curve before. Last time I took an action on this turn, this was the best result, and that's the one I'm going to go towards. So let's break down machine learning. So we have a neural network. These are just a collection of nodes that mimic neurons the same way they mimic biological neurons. You'll have hyperparameters. Hyperparameters are whatever machine learning algorithm you're using. They're dependent variables that control the performance of the actual neural network. And then you'll have parameters, which are for reinforcement learning, it's the current state of the environment. So it's like steering angle, it's speed, it's the XY position of the agent in the current space. Now, I said early on that AWS does a lot of heavy lifting if you want to start out with ML, and especially reinforcement learning. And when I say they do a lot of heavy lifting, they do it. Because normally what you need to do is you need to build your code to do the machine learning algorithm, to do basically update the model based off of the input. You need an environment for the model to operate in, somewhere where it can learn, take photos. So in the case of Deep Racer, you've got AWS RoboMaker, where that holds the agent being the car, the virtual car at this point, and the environment being the track. And it will constantly update its experience from the photos that it takes as it goes around the track, It will then calculate all the math behind that to update the policy using TensorFlow. It uses our NRL coach, and it updates the neural network weights. So this process can take, depending on the model, can take as short as a few minutes. There's some tricks around AI that you can do sometimes to get a really good model. So the whole process of this, right? So AWS Deep Racer initializes simulation on a virtual track. The agent is representing the vehicle and the background. The agent bodies a policy neural network, which is tuned with the hyperparameters, right? And so the agent then takes actions, and as those actions happen, it records what it got rewarded through the reward function. And the ultimate goal in reinforcement learning, and this is like one of the golden rules to remember when doing reinforcement learning, is the bot's goal is to always get the highest reward. So you'll always want to double check, like if you're starting to see behavior that you weren't expecting, double check your reward function, because I guarantee you slipped up somewhere. And I've done it. I mean, I've done it for years where I might have put a less than sign where I meant to put a greater than sign. And then all of a sudden I'm like, oh, okay, I see why. And those syntax errors are hard to catch, because unless you're pre-testing your code to make sure, like, hey, if I input this, I know I should expect this. It's hard to catch on the first try, and so I've wasted hours sometimes just training. So breaking into machine learning, and so there's different ways, like I mentioned before, to start learning machine learning without having to spend money. Deep learning AI has content. Amazon is constantly doing AWS scholarships. So through Udacity machine learning, they've done two of them this year, for example, and they've done them pretty much every single year since I got started. You can learn TensorFlow straight through the TensorFlow website. Google provides coursework directly on the TensorFlow website. There's additional content on that site, which includes books. And then educational things like MIT's through Open Library, they have access to ML courses as well as the mathematics, right? Key things to learn if you're trying to learn this all from scratch, right? You need to know Python. You don't need an extensive background in Python, but you need to understand the basics of key value pairs, JSON, nesting, and if else statements, stuff like that. There's several free tools, like, hey, I don't have the hardware. How can I do machine learning if I don't have the hardware? So there's Google Collaboratory, which provides free ML capacity through what's called Jupyter Notebooks. Jupyter Notebooks is also another good thing to use because it's an analytic tool that's used a lot in machine learning. And then AWS has SageMaker Studio available. So mathematics behind machine learning. So if I wanted to, you came here and said, I don't want to just be a machine learning engineer, because a machine learning engineer really doesn't need to know a lot of math. But I wanted to learn how to actually build the neural networks. I wanted to actually, this would be the roadmap that you would need to follow in mathematics to get there. And all this content I'll provide, but to give you an idea, right? If you're just starting out, a base understanding of calculus is what the article I have linked here recommends. But honestly, I would say linear algebra, understanding it, vectors, space, everything like that is probably more important than understanding calculus right away. Calculus will come in at a later play, but if you're doing reinforcement learning, like if you're doing AWS Deep Racer, linear algebra will take you further than we're learning raw calculus. And so in the end, what is the math behind machine learning? And really ends up boiling down to its being probability theory. And because all the machine is doing is making an educated choice based off the sum of experience and the network weights that it calculated prior to say, hey, I'm 90% sure that's a pair of pants, or I'm 90% sure that I should take a left here and not a right. And that's what it ends up being. So, and then of course, so neural networks here, you want, statistical math will be coming into play, all this, and I could get into more detail on neural networks, but for this I won't, because I was trying to keep this at a high level. It can get very complex very fast, but like I said, you do not need to know this to even get started, because all the tools out there were built around how can we bring more people into machine learning, because we're going to need it, without them having the extensive math knowledge to even build a neural network. And all the tools like TensorFlow, PyTorch, they all provide that underlying resource of not requiring the extensive math. So that's all I have for right now. The key things to remember, right, is if you want to get started, you got to start somewhere. And the free courses, they're always good. Udacity has free courses, MIT has free courses, TensorFlow, and even Deep Learning AI has courses.
Thank you, Mr. Daniel. That was a great session, by the way. So we are moving to the Q&As now. Hope you guys have a lot of questions. So please feel free to unmute yourself or use the chat to ask any questions if you have. Okay, until then, I'm gonna drop some question, Daniel. So,
Sure.
When someone begins their journey in AI and ML, there's a lot of things going on, like too much information flowing, too much research papers coming out, and so many tools like OpenAI and DeepMind is like producing so many tools. So how can someone keep their sanity doing, entering into the field with this lot of information going out there?
Yeah, that's why I think the tools that AWS is providing, I'm an AWS community builder, so me talking them up, I hope people don't see this as bias, but I think that Deep Racer helps get that focus early on to start building the foundation of the understanding of what machine learning can and can't do. Because, like, for example, right, I said to mimic human-like tasks and being able to be able to get results, right? So stuff where machine learning can't produce results would be like predicting the lottery. Why can't it predict the lottery? There's too much chaos there. There's too much entropy in the system, because the numbers that come out of the system are completely random, right? But if it's a human-like task, then we can start predicting it. And so I think starting small and starting in a focused area, like, hey, okay, what's AWS Deep Racer, and looking into it. You don't even have to do Deep Racer, right? Because they have two other products out, which is AWS Deep Composer, if you're more interested in music, right? So you can start learning how AI could write its own music. The other one's Deep Lens, which is, basically object detection, being able to tag and you could write your own model doing something different. And I've seen people leverage even Deep Lens in a manner to actually use it for AWS Deep Racer to detect the lap time around a track. So, you're not limited by just identifying objects when it comes to Deep Lens. You're able to do a lot more. So I think those products, because they're tangible, they're physical, if you can get your hands on them, help you kind of focus and learn the fundamentals really early on.
Yeah, thank you for that. That was a really great answer. Thank you for that. So do you guys have any questions?
And if
Okay,
they have
see my slide.
questions, even after, they can email me. I don't mind.
Okay, so I think we had a brilliant introductory session to AI and ML. So it was very informative, and actually it was very simple to grab, I think. So hope you all enjoyed it. So thank you, Daniel, for joining with us today.
Yep. And so just to make a
Yeah.
comment, right? Remember, I think I mentioned this to you. So I think in December, like if you're interested in learning more, and especially learning more about AWS Deep Racer, just keep in mind there is prizes for AWS Deep Racer. They throw a lot of money at people for AWS Deep Racer. That there will be like a 101 course between me, Thomas, and we Darren, which is Debro, and those two have been two of the main leads in Deep Racer, and Debro is probably one of the people to beat right now.
Okay. So I know, Daniel, you have a lot in your schedule. You have a very jam-packed schedule right now. Yeah. You have your finals coming up.
Yep.
So it was very kind enough to come and give us your time. So wish you all the very best on your finals, and thank you very much. Thank you everyone for joining with us today. So we are gonna conclude the session now. Thanks again. Stay safe, stay awesome.
Yep. Thank you.